Create setup sheets and NC programs for milling. After completing this video, you'll be able to create an NC program, create a setup sheet, and post-process toolpaths. In Fusion, let's get started with the supplied dataset CAM3X Toolpaths Programmed mm.f3d. At this point, we have a design, we have a setup, we have toolpaths that are used to machine the material. Now we need to transfer that data so that it can be used at a CNC machine to cut a physical part. Now there are a couple steps to this process, and the first of which starts with an NC program. From our setup dropdown, we're going to select Create NC Program. An NC program is going to be a container of sorts. It'll connect data between the toolpaths that we've created in Fusion, as well as a post-processor that will convert that data to machine-readable code for a specific machine or controller. This also gives us the ability to select the operations we want and configure some post properties. The first thing that we need to do is select a post. Now remember, if you have selected a machine in your setup, there will automatically be a post associated with that. What we're going to do is select the open icon. This will allow us to navigate through posts. Now, if you have any modified post or downloaded post, they should be stored in your My Post Cloud section. There are also some linked posts, but in this case, we're going to focus on Fusion Library. We're going to take a look at capabilities, first sorting by milling, and then sorting by vendor. For this example, I'm going to use Haas Automation, but you can take a look at any of the post processors available. Inside of here, there are a couple of different options and things that we would want to identify. For Haas, you can see here that there is a next-gen control, which has Inspect Surface, and there's a one below it called Haas Next-Gen Control. This next-gen controller, NGC, is going to be the one that we're taking a look at. And this is typically used on things like UMC machines that have multi-axis. We'll select this, and note that it's asking me to copy this post to my post. We have a cloud location, or we can choose another location. But once again, storing your tool libraries as well as your posts on the cloud means that they'll be available no matter where you log into Fusion. We're going to copy to my posts, and now we can take a look at our program. The information here for name, number, file name, and comment come directly from our setup. They can be changed at this time. We can also dictate where we want our NC program to be saved. We can post it to Fusion Team if you want to store it in your project, and we can also open it in an editor. I'm using a Windows machine, and by default, this will open in Visual Studio Code, unless you specified a different post editor inside of your user preferences. On the right-hand side, we've got post properties. These are things like turning on and off chip transport, whether or not we're using an A, B, or C axis, or if there's any other preferences that we want to control. For our example, we're going to leave everything as default, but note that it is a good idea whenever you're using a post processor to make sure that you go through these settings and validate which ones you need to have on and which ones can be off. Next, we're going to go to the Operations tab. In the Operations tab, this is where we're going to select toolpaths that we want to include. We can bring the entire setup or even multiple setups if they're using different work offsets, and we can also toggle on just individual toolpaths. On the right-hand side, we're going to see everything that's going to be posted. In this case, it shows a work offset of 1, and for our Haas machine, that's G54. It shows us which tools we're using, and there's an option here that we can reorder to minimize tool changes. This only works if we're using multiple setups, and remember that we do need to have multiple work offsets when we're using those multiple setups. We're going to select OK, and now we've created an NC program. I'm going to select the NC program, and I'm going to call this Setup 1. While we never renamed this setup in this design, it is important that we make sure we identify which setups are included inside of our NC programs. You can always right-click, go back and edit those, but keep in mind that just simply naming your setups as well as naming your NC programs is a great first step. Once all of our toolpaths are included, now we can right-click on our setup, and we can either post-process to generate our G-code, or we can create a setup sheet. I'm going to start first by creating a setup sheet. A setup sheet is a document that is taken with our NC program, and it's provided to the machine operator. We need to store it in a location. In this case, I have a subfolder called Setup Sheets, and we're going to place it there. Once the setup sheet has opened, we have some configuration options. By default, a detailed setup sheet will be created, but we can create a tools-only setup sheet, or we can create compact versions that exclude images, for example. We're going to use detailed, and note at the top right, we do have a print option. As we scroll down, there's going to be a summary section, which gives us a general overview about the design that's used, product version and time, the number of tools, the number of tool paths, the minimum and maximum values for things like Z, and our feed rate values. As we scroll down, we'll get a detailed list of our tools, telling us the tool number, the offset values, the number of flutes, the general tool parameters, as well as some of the important things that we have, such as the tool offsets. When we're setting up a tool inside of Fusion, it's important to remember that there is going to be a physical variation of that tool. We need to make sure that the digital and the physical tools match. As we scroll down, you can see here that we've got our setup information, our stock size, the location of our coordinate system, and the WCS number. And below that, we're going to have information about the specific tool paths, the operation, the type of tool path. If we've renamed it, we've got information about which WCS is being used, tolerance settings, stock to leave, and the general information about the spindle speed, feed rate, rapid distance, and so on. So again, all this information is important and critical to setting up the program at the machine. If you simply take an NC program or the generated G code to a machine, you're not going to have the information about where to put your stock, what size stock, and what tools are needed. Next, let's go ahead and right-click on our setup and select Post-Process. If you have any post-processed files or .nc files in the same folder with the same name, it'll ask you if you need to overwrite them. Because I use 1001 and 1002 as these sort of default values, I'm simply going to say yes and allow it to overwrite. But in general, you would want to keep a single copy. Next, as we go through here, you'll note that we have information about the program number, as well as the test at the top, the tools that are being used, and the tool paths. Keep in mind that when you're using programs like Visual Studio Code, there are extensions that can be used. The extensions that can be used include extensions for Fusion's post-processor utility. There are potentially going to be some problems when you're running in restricted mode. In my case with Visual Studio Code, I'm going to trust this post-process code, and that's going to change the colorization of the outputted NC file. This means that we're now seeing Z as a red value, and the X and Y values are shown in yellow. We have feed rate values for this first tool path. The coordinate system reference is G54, and the basic references for things like the spindle speed and its direction. So it's a good idea to make sure that you do give a quick once-over to different areas of your code to make sure that you are calling the correct tools, the correct coordinate system, and you can get an information about things like the Z position when you're getting started. Once you're happy with the NC code, you can take this on a jump drive or a live connection to your machine, and you can begin setting it up and getting ready to run your parts. At this point, we've taken a look at all the steps in the process of setting up, programming, and validating our CNC programs. Make sure that you spend enough time playing around with different models, generating various tool paths, identifying any problems in simulation, and creating setup sheets in NC programs so that way you can take them to a physical machine and begin machining actual parts. Make sure that after you're done that you do have everything saved before you move on to any next steps.